was a little girl, afraid of the big wide world. She grew up within her castle wall.
Okay guys, the definition for Poisson distribution is a tool that helps to predict the probability of a certain event from happening when you know how often the event has occurred. It gives us the probability of a given number of events happening in a fixed interval of time. Poisson probability distribution that can be used to approximate binomial probabilities. So, this is the Poisson distribution formula, where lambda to the power of x times with exponent to the power of negative lambda over x factorial. So let us see the application of Poisson distribution in our real life. Firstly, in factory, the number of mineral water produced in a day. Second, in medical, the number of vaccine injection for baby per week. The next one is in education, the number of students absent per day. And lastly, the number of accidents per day in a city. So, we're going to look about the characteristic of Poisson distribution. Firstly, discrete outcomes. Second, the number of occurrences in each interval can range from 0 to infinity. Third, each event is independent of the other event. Fourth, describe discrete events over an interval. And the last, expected value of occurrence EX are assumed to be constant throughout the experiment. So, what is the relationship between the binomial distribution and the Poisson distribution? Firstly, the binomial distribution tends toward the Poisson distribution as n to infinity, p to 0 and lambda equal to np stays constant. Number 2, the Poisson distribution with lambda equal to np closely large and p is small. Number 3, the Poisson distribution is typically used as an approximation to the true underlying reality. And last, it can be difficult to determine whether a random variable has a Poisson distribution or not. Bang! And then bang again. Okay guys, move to the work example. Okay, first, if 1% of the book bound at a certain bindery have defective bindings, use the Poisson approximation to the binomial distribution to determine the probability that 10 of 200 books bound by this bindery will have defective bindings. Okay guys, for the solution, we were not been given the value of lambda, but we know that lambda is equal to mean and mean is equal to n and p, where n is the total number while p is the probability of success. So, the total number, which is n, is equal to 200, and the probability of success, which is p, is equal to 1%, and it is also equal to 0.01. So, the value for lambda is equal to 200 times with 0.01, we will get 2. So, we need to determine the probability that 10 of 200 books, which means that x is equal to 10. So, we have already known the given lambda and also x, so we just substitute it into the formula. So, we will get the answer of 0.00004. Okay, work example 2. The number of industrial injuries per working week in a particular factory is known to follow a Poisson distribution with mean 0.5. Find the probability that in a particular week there will be less than 2 accidents. And question number 2, in a 3-week period there will be no accident. Okay, for the solution, we have given the value of lambda and it is equal to 0.5. So from the question, there will be less than 2 accident. So, if it is less than 2 accident, which means that x is less than 2, and it is also equal to x equal to 0, plus x equal to 1. So we just find the value for x equal to 0 and x equal to 1. So when we have already find out the value for each of the expected value, so we just plus it and then we get the answer of 0.9098. Okay, for B, in a 3-week period, there will be no accident. The value of lambda, which is the mean 0.5, is only for 1 week. But for question B, in a 3-week period, so which means that we need to find the new lambda for 3 weeks. And we can find it by multiply 0.5 times with 3. So the value is 1.5. So from the question, we need to find the probability that there will be no accident, which means that x is equal to 0, and we just substitute it into our formula with the given value of our new lambda, which is 1.5. So we will get the answer of 0.223. So guys, we move to our best part of today's lesson, that is the exercises. This is to try yourself about your understanding for Poisson distribution. So enjoy! So guys, let us see how to use the Poisson probability table. Okay, for Poisson distribution table, they have two types, which is the first one is the Poisson distribution table and the second one is the Poisson cumulative distribution table. So let us see what is the difference between both of this table. For Poisson distribution table, we can use it when x is equal to any value. For example, x is equal to 1. And for Poisson cumulative distribution table, we can use it when x is less than or equal to x, which is x is less than or equal to 1, for example. So this is the properties for the inequality. Okay, so this is the example for the Poisson distribution table where lambda is equal to 0.5 and x equal to 0 and x equal to 1. So we need to look it in the Poisson distribution table. So the value for x equal to 0 when lambda is 0.5 is 0.6065 and x equal to 1 when lambda is 0.5 is 0.3033. So we write down the value and we add it and we get the answer of 0.9098. Okay, for the second one, we look for the Poisson cumulative distribution table. Okay, we find in the table for lambda equal to 0.5 and x is less than or equal to 1. Okay, for the Poisson cumulative distribution table, we look out for the lambda, which is 0.5. So x is less than or equal to 1, so which means we choose x equal to 1. So the value is 0.9098. So the answer is 0.9098. So from the example that we have done just now, we can conclude that both of the table we can use it because it gives us the same value as the answer. Okay, for the conclusion, a Poisson distribution gives the probability of a number of events in an interval generated by a Poisson process. We can also conclude that we can use the Poisson distribution to find the waiting time between events.